A pleasant greetings to all. In this video, I am going to explain about flip-flop. What is flip-flop? Flip-flop is a single bit storage element. It has two stable states, 0 and 1. And it is a sequential circuit. Next, we are going to see the types of flip-flop. Number 1, SR flip-flop. 2, JK flip-flop. 3, D flip-flop. And the last one is T flip-flop. SR flip-flop is otherwise known as set reset flip-flop. JK flip-flop, other name is Jack and Kilby flip-flop. The name is after the scientist Jack and Kilby. Then third one is D flip-flop is otherwise known as delay flip-flop. The fourth is T flip-flop or toggle flip-flop. In this video, I am going to explain about SR flip-flop or set reset flip-flop. First of all, I am going to explain about SR flip-flop. How the SR flip-flop is formed. SR flip-flop is formed by the combination of 4 NAND gate. The input S is given to gate number 1, R is given to NAND gate number 3, and second input of both are coupled together and clock is given. Output of the first NAND gate is connected to the input of the second NAND gate. Output of the third NAND gate is connected to the input of the fourth NAND gate. And output Q1 bar is connected to the NAND gate 2. Output Q1 is connected to NAND gate 4. And what is Q1? Q1 is the output and Q1 bar is the complement of the output. So what about the symbol of the SR flip-flop? SR flip-flop, two inputs, one is S set and another one is reset. And outputs are Q1 and next Q1 bar. And here you have to connect the clock signal. Inside you have to write SR flip-flop. So this is the symbol of the SR flip-flop. So this is the symbol of the SR flip-flop. Next, I am going to explain the truth table of the SR flip-flop. How to form the truth table? First put S, then R, then Qn plus 1. What is Qn plus 1? Qn plus 1 is the next state of the flip-flop. How to fill the values? First put 0 and 0, then two ones. Or first put 0, next 1, 0 and 1. The first S is equal to 0 and R is equal to 0. This is the case number 1. And the clock is always high. So clock equal to 1. So 0 into 1, that is equal to 0. 0 bar equal to 1. And here 0 into 1, 0 bar equal to 1. Now 1 into Q1 equal to Q1 bar. Q1 bar equal to 1, that is equal to Q1. What about the next state? Next state is Q1 only. This is the case number 1. Next, case 2. In a case 2, put S is equal to 0 and R is equal to 1. S is equal to 0 and R is equal to 1. Clock equal to 1. 0 into 1, 0. 0 bar equal to 1. 1 into 1, that is 1. 1 bar equal to 0. Now, Q1 into 0 equal to 0. 0 bar equal to 1. And 1 into 1 equal to 0. So what about the next state? Here Q1, for the second case, the Q1 plus 1 equal to 0. And next, I am going to explain case 3. In a case 3, what about the combination S and R? S is equal to 1, R is equal to 0. So put S is equal to 1, R is equal to 0 and clock equal to 1. So 1 into 1 equal to 0. 1 into 0 bar equal to 1. Now 0 is multiplied with Q1 bar. So we'll get the answer 0 bar, that is 1. 1 into 1, that is equal to 0. What about the next state? That is equal to 1. And next, case 4. In a case 4, S is equal to 1 and R is equal to 1. So put S is equal to 1 and R is equal to 1. Clock also 1. 1 into 1, that is 1, 1 bar 0. 1 into 1, 1, 1 bar 0. Q1 bar into 0, that is equal to 1. 1 into 0, that is equal to 1. So this is the invalid state. So Q1 equal to 1 means surely Q1 bar is 0. Or Q1 equal to 0 means Q1 bar is equal to 1. But here, both the values obtained are 1. So this is the invalid state or indeterminate state. So this state is no change. This is reset. S is equal to 0, we get Q1 plus 1 equal to 0. So reset. And here S is equal to 1, Q1 plus 1 equal to 1. So set. Then both are 1, the state is invalid and indeterminate state. Next, I am going to explain how to draw the characteristic table from the truth table. Next, I am going to explain how to draw the characteristics table from the truth table. For this, first you have to fill the value Qn, then yes, or then the next state Qn plus 1. Here put the values. For Qn, you have to put the values 4 zeros, then 4 ones. For yes, put the values 2021, 2021. And for R, how to put the value? Alternative zeros and ones. Okay, next find out Qn plus 1. See, S is equal to 0 and R is equal to 0. What about the state Q1? So Q1 equal to 0. When S is equal to 0 and R is equal to 1, what about the next state 0? When S is equal to 1 and R is equal to 0, what about the next state 1? When S is equal to 1 and R is equal to 1, the state is invalid state. So our unknown state. Then S is equal to 0, R is equal to 0, Qn plus 1 is Qn. So Qn plus 1 is Qn, here Qn is 1. When S is equal to 0 and R is equal to 1, Qn plus 1 is 0. When S is equal to 1 and R is equal to 0, Qn equal to 1. When S is equal to 1 and R is equal to 0, Qn plus 1 is equal to 1. When S is equal to 1 and R is equal to 1, the state is invalid. So this is the characteristic table of the SR flip-flop. From the characteristics table, I am going to find out the equation for Qn plus 1. Characteristic equation. So next find out the characteristic equation Qn plus 1. For this, I am going to draw the coordinate map. That is 3-variable coordinate map. The 3-variable coordinate map consists of 2 power 3 8 cells. First write MSB here and then write LSB. Here put 0 1 0 0 0 1 1 1 1 0. Inside 0 1 3 2 4 5 7 6. Next, I am going to fill the values. Here in the side, you have to write 0, 1, 2, 3, 4, 5, 6, 7. These are the decimal equivalents. For 0, put 0. 1, put 0. 2, 1. 3, x. 4, 1. 5, 0. 6, 1. 7, x. Here, have to connect all. This is a quad. 4 cells are adjacent with each other, so they are grouped together. Next, I am going to group these two cells. After finishing this, I am going to find out the characteristic equation. For this quad cell, here there is no common term. Above this, we are having the common term as S. And for this corner cell, here Qn, and here we are having the common term as R bar. So this is the characteristic equation of the SR flip-flop. So after finishing the characteristic equation, we have to find out the excitation table. After finishing the characteristic equation, we have to find out the excitation table. The excitation table can be derived from the characteristics table. So first put Qn, next Qn plus 1, then S and R. Here for Qn, two zeros, two ones. Qn plus 1, alternative zeros and ones. Then find out SR values from this characteristic table. See first Qn. So both are 0 because Qn is 0 and Qn plus 1 is 0. So Qn is 0, Qn plus 1 is 0. What about S? S is equal to 0 and R value 0 and 1. So this is the don't care term because R has two values 0 and 1. Next 0, 1. Q1 is 0 and Qn plus 1 is 1. Qn is 0 but Qn plus 1 is 1. Here this 0 only there. So I have to write this. For the corresponding SR is 1, 0. And then Qn is 1. Qn is 1 and Qn plus 1 is 0. So this is the correct combination. Here put 0 and 1. And then 1, 1. 1, 1. Here we have to take this one and this one. Here we have to take both the ones. And the corresponding terms, S is 0 and 1. Both the values put X. And here 0, 0. We have to put 0. So this is the excitation table of the SR flip-flop. After finishing the excitation table, we have to draw the state diagram. Next, I am going to explain how to draw the state diagram for SR flip-flop. After finishing the excitation table, we have to draw the state diagram. The state diagram can be drawn from the excitation table. Here the state 0. The Q1 equal to 0. The next state also Q1 plus 1, that is 0. So what about SR here? SR 0x. And next, the state 0, present state is 0 and next state is 1. The next state is 1. So now from 0 to 1. So SR equal, SR is, what is the value? 1, 0. And then the signal from state 1 to state 0. What about SR here? 0, 1. And the same state exists, the last one, 1, the next state also 1. So what about SR? SR is X0. So these are about SR flip-flop. Thank you. Have a nice day.